We have the Harvard entrance exam question. If x squared minus x cubed equal 12, what is the value of x? So because this is a cubic equation, we have to get 3 roots. So we can have 1 real roots, then we'll get the other 2 roots to be complex, or we'll get all 3 real roots. So we can use prime factorization to search for the real roots. If they are all 3, then that is it. If not, we search for the other 2 complex roots. So when we factor, this is what we get, and we write 12 as prime factors. So prime factorization is unique. So we can either have x squared equal 3. In that case, it will not work. So we must have x squared to be 2 exponent 2 and 1 minus x equal 3. So when we solve this, x squared equal 4, we will get x to be equal to square root of plus or minus 4, which is negative 2 or 2. Then 1 minus x equal 3 will also give us x to be equal to negative 2. So we have 2 roots. One must be extraneous, one must be the real solution. So we test to see which one is the real solution to this cubic equation. So let's test for 2. So 2 squared minus 2 cubed will be equal to 4 minus 8, which is negative 4. So this is an extraneous solution. X equal 2 is the extraneous solution. So x equal negative 2 should be the real solution, because this will give us 4 minus negative 8, which is 12. So x equal negative 2 is the one real root. So the other 2 roots must be complex. So we have to rewrite this equation. So we have negative x cubed plus x squared minus 12 equals 0. When we multiply through by negative 1, we get x cubed minus x squared plus 12 equals 0. So this is a cubic polynomial equation that we can divide by x plus 2, because x equal negative 2 is a solution. So let's do that. So we have x plus 2 dividing the polynomial x cubed minus x squared plus 0x plus 12. So we divide x cubed by x to get x squared, then we use the x squared to multiply x plus 2 to get x cubed plus 2x squared. We subtract to obtain negative x squared minus 2x squared, which is negative 3x squared, plus 0x. Then we divide the negative 3x squared by x to get negative 3x. Then again, we multiply by negative 3x to get negative 3x squared minus 6x. Then we subtract again to get 6x. We drop the 12. We divide to get 6. So 6x divided by x will give us 6. Then we multiply again to get 6x plus 12. When we subtract, we get 0 here. So it means that the polynomial can be factored as x plus 2 into x squared minus 3x plus 6, x squared minus 3x plus 6 equals 0. So by the zero product principle, either x plus 2 equals 0, which gave us the root we had, or x squared minus 3x plus 6 equals 0. So the x squared minus 3x plus 6 equals 0 is what will give us the complex root. So let's pick it and solve. So we are going to complete the square. So x squared minus 3x will be equal to negative 6. So we add half of negative 3 all squared to both sides. Half of negative 3 all squared to both sides. So we get a perfect square on the left hand side. So that will give us x minus 3 over 2 all squared is equal to negative 6 plus 9 over 4. Negative 6 plus 9 over 4. So let's simplify this. The LCM is 4. That will give us negative 24 plus 9, which is negative 15 over 4. So when we take the square root of both sides, positive or negative square root, we get plus or minus square root of 15 over 4 times square root of negative 1. And recall that square root of negative 1 will give us I. So square root of negative 1 is equal to I. So we proceed with our solution. X will now be equal to 3 over 2 plus or minus square root of 15 over 2I. So you have either x equal 3 over 2 plus square root of 15 over 2I, or x equal 3 over 2 minus square root of 15 over 2I. Hence, we found the three solutions. X equal negative 2, x equal 3 over 2 plus square root of 15 over 2I, or x equal 3 over 2 minus square root of 15 over 2I.